Another integral part of our vision is how we perceive depth. How do we perceive how far objects are, the depth of objects, the three-dimensional shape of objects? Okay, and actually, it's a complex phenomenon, and I'm not sure how fully clear is that in the scientific community. But there are some factors that we agree on. I picked this up from How Stuff Works website. Okay, one of the things is memory, the size of known objects that we have in our brain. If we know already the size of an object, we can gauge how far it is based on the size that is going to form on our retina. So if it is a small image on the retina, we are going to think it's far. If it is a large image, we are going to think it's close. Moving parallax. We are very dynamic individuals. We move quite a bit, and our eyes move quite a bit. So actually, when we look at something, we are not going to have one static image made on our retina. Our eyes move too much, and we move quite a bit actually. So there will be a multitude of images of that object that's going to form on our retina. These images are going to move rapidly and change rapidly. Now, objects that are close by, as we move our heads or our eyes, the image they make on our retina is going to move quite a bit. However, objects that are far away, the image is not going to change much, or it's not going to move much on our retina as we move our eyes. This way, the change in the image helps our brain figure out how far an object is roughly away from us. Okay, now that's an interesting thing as well. For example, people who are one-eyed, who lost vision from one eye, they compensate for that by moving their head and their eyes much more in trying to view things. Okay, and actually that's related to stereovision as well. Remember that our eyes are about 5 centimeters apart, about 2 inches apart. That means the perspective of each eye when it looks at an object is going to be different, which means that we are going to have two different images. Each eye is going to see a different image from the other one, a slightly different image. Now, of course, close by objects are going to result in images that are much more different than further away objects. But the difference in images, our brain is going to analyze as well and come up from there, from the distance where an object is, or 3D features of the object. So a one-eyed person is not going to have that stereo vision, so they compensate for it by increasing the parallax, the moving parallax. One thing, just to make sure that we understand, we have the same object here, a candle. But when it is far away, it's going to form a small image on the retina. When it is close by, it's going to form a large image. So actually, the angular size of the object as it enters our retina is going to help our retina determine how far away the object. Stereo vision, just an image here. If we are looking at an object here, one eye is going to see something like this, while the other eye is going to have a different perspective, so it's going to look slightly different. In putting them together, we see 3D. There is an implication to this. I think most of you, if not all of you, have seen 3D movies. And in these cases, what they do, they make you wear glasses. And what the glasses are going to do is, one of the eyepieces is going to allow one image to pass through, while the other one is going to allow another image to try to duplicate what happens in reality. So the 3D movie glasses, in 3D movies, they are going to send a sequence of images. One image and then a slightly different image, very short time afterwards. And then a slightly different image. They alternate between images. And then the glasses are going to permit the eye to see only one of those images. So one eye sees one series, and the other eye is going to see the alternate series. And these images are pre-programmed to be slightly different. So each eye is going to see a different image, and that's what's going to give us the 3D vision. Now, in some cases, and actually around the 90s, it made the big news, but it never made it into production. There were a couple of professors from the University of South Carolina who actually devised a way for viewing 3D pictures, 3D TV pictures, without using glasses. In their case, what they banked on is the moving parallax. So instead of having two different pictures, they kind of created some motion in the image, and that motion was given the viewers the perspective of 3D motion.